Electric flux is a measure of, I guess you could say, how much electric field is going through a surface. If you have an electric field going to the right, and say you have a surface here, which, if you, this is just an end view, this might be a square or a circle or something, if you orient your surface in another direction. But the combination of how much field there is and how much surface it's passing through and the angle is what determines electric flux. Now, you can kind of guess and see that if it's perpendicular, there's going to be more flux than if you're at an angle, because if you're at an angle, then there's going to be less of the field that is passing through the surface, right? So there is a trade-off there. As the surface rotates, you get less flux going through it. The formula for flux is this, which is the Greek letter phi. It's a capital phi, stands for flux, electric flux, and that is equal to the E field times cosine theta times the area. The trick here is that this theta is the angle between the E field and the normal to the surface. Okay, so we're not talking about this angle, we're talking about this angle right here. All right, so you draw an imaginary normal to the surface. So, if I tell you that there's a constant E field of, 1.3 times 10 to the 4th newtons per coulomb, and it's hitting a square with side 2 centimeters, so that the field makes an angle of 35 degrees to the surface. I want you to find flux. We're just plugging it into the formula. Our flux is equal to, sorry, I paused and I don't know what I just said, but so flux, we've got E field, 1.3 times 10 to the 4th, times the cosine of theta. Well, remember theta, just be careful that you are remembering that theta is the angle between the normal and the E field. So if the field makes an angle of 35 degrees to the surface, that means that this angle is 35 degrees, which means the angle between the normal and the surface is the complement of that. So that's cosine 55 degrees. Or you could plug in sine 35 if you wanted to. That's equivalent to cosine 55. Times, and then the area is square with sides 2 centimeters, so that's 0.02 squared. And we can punch that into our calculator to get the flux. Flux is an E field times an area. This comes out to 2.982, etc. Electric field is newtons per coulomb, and area is meters squared. So flux is Newton meters squared per coulomb. And there actually isn't another unit for, there isn't a special unit for flux. It just is Newton meters squared per coulomb. And one thing that is worth noting is that if you have an enclosed surface, say you have a sphere or a cube or something that you're looking at, the flux is positive for E field going out of the surface, and flux is negative for E field going into the surface. So keep that sign convention in mind.